Okay, Algebra 2 fans, our topic for today is solving radical equations. And before we start, let me tell you your joke of the day. Did you hear about the statistician who drowned crossing a river? It was 3 feet deep on average. Okay, so our goal for today is we're going to solve equations containing radicals. And to do this, to start, we're going to go back to take a little trip down geometry lane and talk about the Pythagorean theorem. Pythagorean theorem says that when you have a right triangle, the two legs, A and B, and then the hypotenuse is C, A squared plus B squared is equal to C squared. So let's find the hypotenuse if the legs of a right triangle measure 5 and 12 respectively. So what we've got here, let's draw the picture. 5 and 12 are the two legs. I'll call x the hypotenuse. So we do 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. Add that and we get 169. Now 169 is equal to x squared, but that's not the solution. We're not solving for x squared, we're solving for x. To undo a square, we have to square root both sides. The square root of 169 is 13. The square root of x squared is just x. That's how you know it's solved. When you get x equals a number, that's how you know you're done. So the idea is that to undo a square, you have to square root both sides. Here's another example. 2 raised to the 5th is 32. If I take the 5th root of both sides, what I get is 2. All right? That taking the 5th root of this will undo the exponent. So if you want to undo a square, you take the square root. If you want to undo a cube, you take the cube root. And it works the other way. If I want to undo a cube root, I raise it to the 3rd power. If I want to undo a square root, then what I do is I square both sides. I raise it to the 2nd power. Okay, as an example, if I say the cube root of 125, if I want to undo that, I cube it, and what that leaves me with is 125. Okay? So, for solving radical equations, here's our goal. So, step 1, the goal is to solve for the variable, so you want to get x equals a number, or a number equals x. Get the variable by itself, what number equals x. Isolate the radical by moving all other numbers to the other side. Get the radical and the variable on one side, get everything else on the other. Square both sides to eliminate the radical symbol, or to the cube, 3rd power, or the 4th power. Solve it, check it. Okay, so for example, number 1, square root of x equals 8. To undo that square, I'm going to to undo the square root, I'm going to square both sides. So what I get, the square root of x squared is just x. And 8 squared, 8 times 8 is 64. And that's it, that's my answer. If I plug that back in and I check it, if I do square root 64, okay, that's 8. Now you can just check these on the calculator. So square root of 64 is equal to 8. Okay, so everything works out. Number 2, square root of 3x minus 2 equals 4. So again, I've got my radical on the left side. I've got everything else on the right side. I'm going to square both of these. So what happens when I square a square root? The square root basically cancels itself out. We get 3x minus 2 equals 16. Now it's a normal equation. Plus 2, we get 3x is equal to 18. Divide by 3, and we get x is equal to 6. Now again, you have to check your answers because they don't always work. If we put a 6 in, 3 times 6 is 18, minus 2 is 16. The square root of 16 equals 4. Check. Everything works. Now on number 3, before we square both sides, let's take the 5, let's move it to the right. So what we get is the square root of x minus 3 equals x minus 5. Okay, so now what we're going to do to get rid of that square root, we're going to square both sides. And the left side becomes x minus 3. Now on the right side, got to think about this here. The x minus 5 to the second power, that's the same thing. I'll do it up here. That's x minus 5 times x minus 5. And so what happens there, we would do x times x is x squared. We would do x times negative 5 is negative 5x. Then we would also distribute this negative 5, that's negative 5x again, and then negative times negative, that's positive 25. And so what we end up getting here, we combine the like terms in the middle. We get x squared minus 10x plus 25. X squared minus 10x plus 25. Now I showed you a quick way of doing this, where you could square the first term x, square the last term negative 5, which makes a positive, and to get the middle term, multiply these together and then double it. So that's negative 5x times 2 is negative 10x. Okay, so now we need to solve this. Well, now you have a quadratic. In this case, we actually want everything on the same side. I'm going to move the x and move negative 3. So I'm going to go minus x plus 3 on both sides. I have to do this on both sides. We get 0 equals, that's x squared minus 11x plus 28. All right, to solve a quadratic, let's try to factor this thing. So on the side, what we're thinking here, can we think of two numbers that multiply to 28 that add up to negative 11? And when you think of factors of 28, well, how about 4 and 7? And in this case, I'm going to say negative 4, negative 7, because it has to multiply to a positive, but it's got to add up to negative 11. So what we get here is 0 equals, that's x minus 4 times x minus 8. Times x minus 7, excuse me, times x minus 7. Okay, now we're not done. We need to solve it. These are the factors. We need the solution. Each factor, we need to set that equal to 0. So maybe x minus 4 is 0, or maybe x minus 7 is 0. Now if I solve this, I'd go plus 4 plus 4. So one answer we get is positive 4. Now over here, x minus 7 is 0, I'd go plus 7, and I'd get x equals positive 7. Now the question is, do both of those work? If I plug a 4 in for this, that would be square root of 4 minus 3, which is 1. Square root of 1 plus 5, that's 1 plus 5, which is 6. But my value for x is 4. 4 doesn't work. That's not going to make this true. Okay, and let me show you again. Let me show you where I do it on the calculator here. So if I plug a 4 back into the original problem, square root of 4 minus 3 plus 5, I should get 4, but I don't. I get the number 6. So that's no good. That's what we call an extraneous root, extraneous solution. 4 doesn't work. Okay, how about 7? If we do square root, and we're going to do 7 minus 3, 7 minus 3 is 4, and the square root of 4 is 2, and then plus 5, 2 plus 5 is 7, which is what the x value is. That would actually work. Okay, so 7 works, but 4 does not. Okay, and you'll notice that when I write this, I put this in a solution set. I could do this. You don't have to do this. I could have done it also for number 2. The set of solutions is the number 6. Here it's 64. Sometimes you'll see it written this way, and that's fine. Okay, so some of these you're going to end up having to factor. You have to be very careful. Go step by step as you do this. Step by step, and it'll work itself out for you. All right, so now on the bottom here, let's take number 4. You have two radicals, and they're both on the same side. That's not a good situation. What we'll do, let's move this negative square root 2x plus 7. Let's move it to the right side. We're going to add it to both sides. So what we'll get is square root 3x plus 2 equals, that's going to be positive square root 2x plus 7. Because what I did was I added here and here. So to move this whole thing, I'm going to go plus, plus. Now actually, this looks kind of confusing, but how do you undo a square root? We have to square both sides. So by squaring the sides, we're going to undo that radical. We get 3x plus 2 equals 2x plus 7. Wow, this is actually not a bad equation now. Let's move 2x. We'll go minus minus. So we get x plus 2 equals 7. Let's go subtract 2. We get x equals 5. And that's our answer. Now let's check it. If I put a 5 back in here, I get 3 times 5 is 15 plus 2. That's square root 17. Okay, minus 2 times 5 is 10 plus 7 is also square root 17. Square root of 17 minus itself is equal to 0. So this is good. That's our answer. Okay, so I'm going to stop there. That's part 1. And we'll come back and do the last 3 problems for part 2.